So in this video, we'll be talking about the general method of bacterial classification. The general method of classifying a bacteria. General method of bacterial classification. Bacterial classification. We can classify bacteria based on different criteria. So you can classify bacteria based on their different criteria. You can classify them based on their oxygen requirements. Then we have the obligatory aerobe, the facultative anaerobe, and facultative aerobe. We can classify them based on oxygen requirements. We can classify them based on their gram staining technique, which you can call it based on cell wall classification, where we have gram negative and gram positive bacteria. We can also classify bacteria based on their mode of nutrition. We can classify them based on shape too. Based on shape, which we discussed earlier, where we have the cocci bacteria, the bacilli bacteria, the vibrio, the spirochetes and spirillum bacteria, and the unusual type, which is the mycoplasma. So yeah, we're talking about oxygen requirements, classifying bacteria based on oxygen requirements. So there are three major types of bacterial classification based on oxygen requirements. We have the first one as the obligatory aerobe. Obligatory aerobes. So what are obligatory aerobes? These are bacteria that live in oxygen-rich environments. Okay, they inhabit oxygen-rich environments, and oxygen aids in their growth and cell modification. So the absence of oxygen can be detrimental to their growth. So basically, they ask you what is an obligatory aerobe. An obligatory aerobe is a bacteria type that inhabits oxygen-rich environments, and the absence of oxygen can be detrimental to their cell growth. Now they can ask you in your OBG question that which of the following organism is classified or is an example of an obligatory aerobe. So when they ask you that kind of question, you are expecting to see the like of your Mycobacterium tuberculosis, your Mycobacterium, which is one of the organisms that was used by Robert Koch, in his postulates for germ theory. Mycobacterium tuberculosis. You also have the like of your Pseudomonas aeruginosa. Pseudomonas aeruginosa. And also you have the like of your Streptococcus pneumoniae. Pneumoniae. So these are examples of an obligatory aerobe. So if they ask you what is an obligatory aerobe or which are the following is an example of an obligatory aerobe, you should be looking out for the Mycobacterium, the Pseudomonas, and the Streptococcus. Now we also have another bacteria type based on oxygen requirement, which we call facultative aerobe and facultative anaerobe. Those are the ones that can live in the absence of oxygen. And when I mean live in the absence of oxygen, that means with or without oxygen they can survive, and those ones respire via fermentation in the absence of oxygen. So that's what we're talking about now. So we have the facultative aerobe or the facultative anaerobe. For the second one, we have the facultative aerobe or anaerobe. These are bacteria that can survive in the presence or absence of oxygen. That means whether oxygen is there or oxygen is not there, they can survive. These are bacteria that can survive in the presence or absence of oxygen. Then it's also important for you to know that they respire via fermentation via fermentation in the absence of oxygen. In the absence of oxygen. So now in your option, you should be looking for the likes of your Salmonella typhi. You should be for like examples of facultative aerobe and anaerobe. You should be looking for the likes of your Salmonella. Examples are your Salmonella, let's say your Salmonella entericus, your Salmonella typhi, anyone. You should also be looking for the like of your E. coli, your Escherichia coli. So now if they ask you your question, what are facultative aerobe? These are bacteria that can survive with or without oxygen. They reproduce via fermentation in the absence of oxygen, and they ask you which of the following organism is a facultative aerobe or a facultative anaerobe. You should be watching out for your Salmonella species and your Escherichia coli. Also, the last bacterial classification we'll be talking about for today is the obligatory anaerobe. The obligatory anaerobe. So these are bacteria that cannot survive in the presence of oxygen. The presence of oxygen can be very detrimental to their health. So these are bacteria that can't survive in the presence of oxygen. Oxygen can be detrimental to their cell growth. Now when they ask you for an obligatory aerobe, you should be looking out for your Bacteroides fragilis. Examples of your obligatory anaerobes rather. If you're looking out for your Bacteroides fragilis, you should be looking out for your Clostridium species. Let's say your Clostridium tentenni. So if they ask you your question, define a facultative anaerobe. Now you know that a facultative anaerobe is a bacteria that only survive in the absence of oxygen, and the presence of oxygen can be detrimental to their growth. And examples of this facultative anaerobe are the Bacteroides fragilis. You also have your Clostridium tentenni. So this is one specific way you can classify a bacteria based on oxygen requirement, which we discussed here. So now we'll be talking about classification of bacteria based on cell wall, where we have the gram-negative and the gram-positive bacteria. It's also important for you to know that the two equipment we use to test or do the gram staining technique is what we call the crystal violet and the safranin. They can ask me your OBJ question, but we're going to discuss that soon. Okay, so now we'll be classifying bacteria based on their cell wall. What we call the staining technique. And it's also very important for you to know that what we use to do staining technique for bacteria is what we call the crystal violet or the safranin. And you should know that the gram-positive bacteria will retain purple coloration. Gram-positive will retain purple coloration, while gram-negative will retain red or pink coloration. And now you also need to know that retain purple coloration due to the absorption of the crystal violet, while your gram-negative due to the safranin to retain your red, or sometimes you see it as pink coloration. Now you need to know that the classification of bacteria based on cell wall is divided into two. Like I said, we have two classifications based on cell wall classification, which is the gram-negative and your gram-positive bacteria, which is your gram-negative bacteria, and you also have your gram-positive bacteria, or gram-positive bacteria. So what are gram-negative bacteria? Generally, we know that the cell wall of bacteria is made up of peptidoglycan. And what are peptidoglycan? They are modified glucose, okay? They are also called murines. If you don't see peptidoglycan and you say murine, is also very correct. And now, murines are made up of two things. They are made up of NAM and NAG. The cell wall of a bacteria is made up of what? It's made up of peptidoglycan. And peptidoglycans are made up of what? They are made up of murines. What are murines? They are made up of murines. Murines are modified glucose. Because if you don't see peptidoglycan in your option and the same urines, they are very, very correct. These are modified glucose. And these neurons are made up of two things, what they call NAM and NAG. So you can also see that your bacterial cell wall is made up of muramic acid. Very correct, because this NAN represents N-acetylmuramic acid. N-acetylmuramic acid. And this one is N-acetylglucosamine. N-acetylglucosamine. So they ask you which of the following bacteria have a thick peptidoglycan cell wall. That's why you're talking about your gram negative. This gram negative have thick peptidoglycan cell wall. By your gram positive have thin. Gram positive have thin peptidoglycan cell wall. So now there are basic examples and there are various examples of your gram negative and your gram positive bacteria. When I'm talking about your gram negative bacteria, I'm going to give you a mnemonics you could use to learn it. You can use the word PENS, P-E-N-S. PENS. So they can ask you, list 5 examples, mention 4 examples of a gram negative bacteria. That's why you're talking about your P is for your Pseudomonas. Your Pseudomonas aeruginosa. Your E is for your Escherichia coli, your E. coli. Your N is for your Neisseria species, Neisseria gonorrhoeae. Your S is for your Salmonella typhi. So they can ask you which of the following in the option is not a gram negative bacteria. That means you should be looking out for something that is different from the. There are many more examples. You have your Klebsiella. Your Klebsiella is also a gram negative bacteria. So there are various examples of a gram negative bacteria that you should be watching out for. But these are just the few examples that you need to know. Then for your gram positive bacteria, you can use this mnemonics BCS squared. Then your B represents your Bacillus anthracis. Your C is your Clostridium species. Your Clostridium could be your Clostridium tentenni, could be your Clostridium entericus tentenni. Then your S is your Streptococcus pneumoniae. Then the other S is your Staphylococcus aureus. So these are the gram negative and gram positive bacteria. So in case they ask you which of the following bacteria have thick peptidoglycan cell wall, you should be looking out for your gram positive bacteria, which are your Bacillus, your Clostridium, your Streptococcus, your Staphylococcus. Even your Enterococcus is also a gram positive bacteria. There are various examples you need to know, but these are the major ones you need to know for now. So this is classification of bacteria based on cell wall, and now we're discussing classification of bacteria based on their mode of nutrition, where you have your symbiotic bacteria, you have your parasitic bacteria, and the rest of them. So that's what we're talking about in the next video.